Hello and welcome to another video on this journey that starts with Redux, specifically Advanced Redux, Redux RTK, and how that lead us to understand is first is the fundamental of Redux. What is this particular library allows to do, which is the state management. And as we explore the Redux API and understand what the things offer to us, which is an object that is follow the Flux architecture as a way of how can we now is update our state in a maintainable and predictable way. So on that, we have to recognize and put a practice also to refresh our knowledge in terms of Redux, that this is something that will allow us to manage our state. So this is an object, and this is the shape of this object. Okay, this store that is exposed to us, and they have now this particular Flux architecture. So it exposes the state, the get state, the get state method as a way to get the state out of this. So it exposes that method, the dispatch as a way to update the state, the reducers, and the subscribers as a way to now let this set of functions subscribe to this state whenever it changes, right? And what are the tools that Redux provide for us? So for example, like compose, which is allow us to now trigger this set of functions in a particular order. And how can we now use some of the things like create actions, and what create action is doing behind the scenes? What are the things that it automates for us? This particular way of creating or setting actions in their format, part of the Flux architectures, and how we can now combine that with our reducer, this state update logic, and how can we now combine several of these reducers into one with the combined reducer to modularize all of this state update logic per state as a way to make it much more easy to debug. And then how things like enhance allows us to now incorporate some of these features that are now, well, extension but of the Redux, and one of them is the Redux dev tool. Okay, and when it comes to now intersect the communications between or the execution between the actions and or the dispatcher and the reducers, how we can use middlewares as a way to, most of the time, is perform some async operations, right? So this asynchronicity, especially when we have to do things like thunks, where it's a funny concept, I don't know what they're smoking, where they come up with that phrase, but this thunk concept is something that is not specifically to Redux or JavaScript itself. It's something that predates JavaScript. And this is a way of how can we now make our state updates by putting all of this asynchronous logic separate from the act of updating our state. So because this asynchronicity is something that, especially with thunk, I wasn't aware of what thunks are and what they're doing. Okay, that's why I have to create I create this docs based on this rethinking asynchronicity in JavaScript, which is a course taught by Kyle Simpson. Shout out to Kyle Simpson, man. Shout out to you. And the idea, so here is just to understand how all of these particular concepts, specifically the asynchronicity concept, and then how you can apply that to your JavaScript applications, or for any time you need to deal with asynchronicity in a program, we are able to see what are the patterns that are used, which is something interesting. This is not exclusive for JavaScript. So this is something that you can work and use among other programming languages. But here, this is exclusively is with JavaScript. All right, so this is now the topic that we went over through. We talk about parallel and asynchronicity, callback things, and here we're going to talk about promise. Just to make a quick recap of how do we get here with promises, is to understand that parallelism and asynchronicity is two different things. They have their own particular concepts. So parallelism for the computer sense is quite different from the human perspective, specifically the cognitions. So it is quite different from the human. So this parallelism is quite different from what we think about that, especially for any cognitive task. So in that sense, we are not parallel. In fact, we are more asynchronous, we are more concurrent, but unless you talk about is the biological aspect of what are the things that need to happen at a second to keep us together. Whereas parallel in the computer sense is tasks that is going to pass through all of these different threads and they execute it at the same time, right? So because computers now have all of these particular threads, whether it's 8 or 12, 16, 32, you can imagine that an OS will need more threads than that, because running a web browser by itself in Mac 14 Sonoma, running a Chrome instance, when you take a look at the task manager, you actually see that it's only 4 threads that is using, just for the sake of being there. And the difference between the process and the thread is that a process is this complete independent program with its own memory, all right, that can now run threads. What they can have is threads. So the way of how now all of these independent process or programs can communicate is through the intercommunication process, okay, which is some sort of bus that you can pass data through that. And this IPC, most of the time, let me see if actually I put it here. This IPC, let it do that. I don't believe it. Well, this IPC, okay, is a way how you can communicate all of these different process programs, okay, and they do that whether it's using pipes, which is one-way communication, using socket, this two-way communication, whether it's Unix or TCP sockets, also memory. So this is like a whiteboard, and this is when you have now things like resource sharing. If you are working with multi-threading, message queue, so like a POS service. So for example, MQTT actually uses that as a way to now pass all of these different message to different process, and the alerts or the signals like emergency calls, right? This is just this particular way of how can we now is communicate one process across another, okay, through the IPC. And the threads are just this small unit of execution inside of the program. So because our JavaScript programs run in a JavaScript engine, which is something that has the browser or the server, and they execute line after another. That's what they call is single thread. Web workers is now this idea of how you can make or how you can bring parallelism to the language by actually running its own process, particularly its own threads, but we call them process because it actually created its own JavaScript engine with its own memory, right? So you can communicate to this particular thread, worker thread, sending message, and with the notions of the event loop, with the notion of the event loop. However, this is not a feature from JavaScript. This is a feature from browser or from the platform, the web or the server. And since at the end of the day, we're writing this JavaScript application, and especially this is true for UI interface, that we need to deal with all of these things that can happen, all of these tasks that overlaps over time or concurrency. We need to develop some better patterns as we write these applications, and we solve now more complex sorry, and we now solve more complex problems in our JavaScript programs by handling this concurrency. So the next level of competency in the JavaScript developers is that you are going to deal with this concurrency nature of your async programming. And that's why we need to be tactical and strategic when it comes to develop this kind of applications. That's why it is important to recap and have a discipline to understand all of this particularly JavaScript or particularly async patterns, to understand how does it work and see that even though that the callback is something that we can use for any of all of these applications, right? It's not this callback is insufficient when it comes to describe this more complex scenarios that we're dealing as a JavaScript developers when building these kind of asynchronous applications, right? So even though that we look at the callbacks, which is now come from the web platform, which is set timeout, you pass the callbacks, and the callback here is not about we also look at the callback hell, which is especially more like an aesthetic thing, but it doesn't solve the true problems of the asynchronicity that we need to deal with, right? And that is how we coordinate is, for example, when you are sending a lot of requests to a server, okay, how we going to now is handling all of the how we gonna handle is this concurrency, okay, and so how we're gonna handle is sending all of these requests usually how we're gonna handle is a response. So by sending all of these requests at the same time, how we're gonna handle is the time that we need to wait for them to come back, and also coordinate its response. Respond as soon as they are available, and show them in the proper and only the correct order that we call them, right? We also see a particularly painful exercise to do that, and that was, my friend, it works. It works, all right, but it's something that this callback thing uh, show us is some of this particular issue that we have with the language. And one of them, especially when QA started to ask several questions about your code and then you don't know how to reply them, that's when things started to get quite messed up. uh, so shipper is Mm-hmm. Anyway. Anyway, so is this right? Is this how it's now working with this in the AC? So, because we are writing in some JavaScript applications here, and most of the time we have to, yeah, as I mentioned before, we have to deal with this concurrency and with the callbacks, and how now the callbacks is this continuation of the code at some point in the futures. And because of this has a particular way of writing your application that it doesn't solve the problem of the trust issues generated when we need to actually use it, which is you don't want to trigger this, you don't want to trigger, so please don't trigger, please don't trigger too late, too early, too many times, especially too many times, too few times, no lost context, so no shallow errors, which is one of the reasons why this thing, especially this inversion of controls, happen. And that is when you pass now this code to the callback as a way to now run that at some point in the future. But you now you invert control. You put them in control of when and how this code will execute, right? And not only that generates some of these trust issues, especially if you use third-party libraries that are actually using callbacks, all right? It's also not reason about it, especially when it comes to readability, because now, after all, JavaScript engine is running all of our code line after another. Here we need to actually wrap them one inside of this nested thing. So there's some solutions that come up here, right? Or something called like known fixes. You put them in a separate callback. That seems to be a very not good approach. And the other is the error first style, which is something that we're still using in today as a way to handle this callback. And by the time that function was called, we actually get that the first parameter is the error and the second parameter is the number, which is something that we're gonna see that in promise as well, but with the reverse order, okay? And the nested callbacks. However, none of this solves the problem of how our brain works, especially as we write code, as we plan things in this sequence blocking order, right? So there is a theory that when the human brain diverges from how the JavaScript engine works, that's when the cause of the bug happened. And there is a reason why actually we're taking it this. So as a way to make this asynchronicity a little bit much more easy to work with, so thunks solve is a particular problem what we have with callbacks, is that we need to actually coordinate when those response kicks in. So at some point we need to actually manage time. And time is one of the most complex factors that we have to deal in programming. So thunk is this very weird word that I don't know where it came from, that from the synchronous perspective is a function that is a function wrapper that has everything that it needs to get a value out of it. So this will act as a token across your program, so anytime you call that, you're gonna get that value, right? So if you combine this with the asynchronous perspective, where instead of actually get a value back, so instead of just having only a function wrapper that got everything that it needs, but when that value comes in, we need to know how do we get that. That's why we pass here a callback. So when we use this, which is a very interesting thing, all right? So we are now using is this function wrapper around a function that'll take some amount of time to complete, and by the time that is done, we now are capable to call this, we're now capable to pass a callback to get the value out of that. So this is huge because we now isolate the time for our applications. So we eliminate time as a constraint, as a concern in our code by just only having this particular function wrapper or this token, and I'm going to pass now a callback here, all right, that is going to by the time that value is there, I'm gonna now get that value passing this callback. So you may wonder who is actually storing this value thing here, right? Well, closures, which is a JavaScript features that allows us to hold the reference of a function. It allows to hold the outer lexical environments of a function, and allows to access them inside of this function. So in other words, this is like this backpack that we pass into our functions that allow us to that allow us to carry over, that allows to retain some data, to store some data, and now by the time that is done, pass the proper callback function, pass the proper function to get out of that. So this is huge, bro. This is huge because not only that we also look at particular function to make now to make a more generalized. That's what's very interesting. That actually is skills in JavaScript developers. Because now that we look at how can we create this async function or create this async thunk. So by the time now is this thunk will be called, we know that we're gonna get the value out of this, right? So here is this piece of code is very interesting just to describe that here what we're doing is we are now assigning a new spacing memory, an array-like, but this is not a traditionally array-like. This is not a continuous spacing memory, at least not in JavaScript. In JavaScript, it is more like an array list. Okay, so that's why you have now this flexibility with this particular data structure, that you can now resize the dimension of this array as you see fit, right? So this we're telling to JavaScript, hey, please create this. So reserve spacing memory without elements for this array linked list, or for this array list, that it has now a method called slice, that by the time I call them, okay, this is the context, this is the data that you're gonna use here in this array, in this function, okay, and this is the argument that you're gonna get. So that's one of the reasons why here we're passing is the arguments and as one, right? So it means that here we're receiving is this function reference, okay, or this initially here we're receiving is the first arguments as the function, followed by the arguments that we're gonna use to get all of these arguments, to get all of these arguments in an array, okay, hold that reference, okay. So after you run this function, after you evaluate this function, I want to hold this reference of the arguments, store them persistently, okay. And by the time now I run this, or by the time I call this thunk, okay, I want you to now is not only receive the callback, okay, but also the functions that I pass here initially, I want to is add that, or in this case, I want you to now is pass the attach the callbacks to this sequence at the end. So attach the callbacks to this array of arguments, and then pass that arguments or pass that array to the function that is gonna need that. So this is just as a way to make this thunk general purpose. That's interesting. That's neat, bro. That's dope. That's dope. Absolutely. So, here we are. This is it, right? Add async. That's right. Yeah. Okay, cool. Yep, cool. So by the time we did this, all right, these general functions, we also look at how can we actually use that thunk in an asynchronous fashion, right? This again doesn't solve the problem of readability, but it solves the problem of time, especially when dealing with this concurrency, this task that overlaps at a time. And so we're going to see here, so this is important here, the thunks and closures, right? So this is huge, and especially when I look at how you can use now your tools here for simple things to do, right? As a way to now is coordinate is our response for that. That is very interesting, very interesting. There is a link. I'm gonna leave that for this as a way to see how that in my case I have years writing crappy code, and I didn't understand how my tool works, right? And that actually is something that is here. So we're using with the use of closure, all right, as a way to now is handle this coordinations. And the closure is that, hey, let's going to now store this at some point that you might need it or not, right? But I'm going to store this or the text or the response or the function in itself. When I look at this pattern, initially, perhaps you are not going to get that at the beginning, because it's like, what in the F is this? But what we're doing here is that by the time we now call our, by the time the data is here, we're going to store that into So we're going to store that the data, okay, in a closure, and now let's going to actually call that function respectively with the data. However, this function that we need to register first by the time we run this function, okay, it'll be the particular callback that we're gonna that we want to store, by the time that this data comes here, we want is to now pass the reference of the callback with the data in itself. So this particular thing that can be quite problematic and hard to do, now is very simple. It is very straightforward, because here the problem is, how do we handle this coordination? Okay, so that might be quite somewhat patterns that we can use here as a way to now is use a closures to manage all of this concurrency, which is a great thing. All right. And that's exactly what we're gonna see in today's video, which is promises. Let's get into this, right?
What is a promise? There are a multitude of different ways, several different ways that promises are explained, and I will choose 2 or 3 of those explanations here by way of metaphor and illustration. Again, because it's more...
So what is a promise? So what is a promise? Here we are going to see, careful. What? No, what is a promise? What you trying to negify this one? Anyway, here we go. Here we're going to see, right? Here we're going to see. Yeah, what is a promise? Here we're going to see is multitude.
Different ways that promises are explained, and I will choose 2 or 3 of those explanations here by way of metaphor and illustration.
So what's a promise? So here we are going to use 2 or 3 metaphors. Metaphors. We're going to use 2 or 3 explanations. Okay, 2 or 3 explanations here by way of metaphor. 2 or 3 explanations by way of metaphor. And illustration. Because at the end of the day, we make sense of the world through stories and visualizations. Okay. So here we're going to use 2 or 3 explanations by way of metaphor. Okay, 2 or 3 explanations by way of metaphor and illustration.
Again, because it's more important to me that you understand the concept behind promises first.
Because it is important to understand the concept behind behind promises. Before understanding the API.
Before understanding the API. It's the reverse of the way most of this stuff is typically taught. But I want you
to... And it is reverse what most of these topics are taught.
To understand why promises are so important.
In exactly the concept behind promise, before understanding the API, it is reverse. It is a reverse. It is reverse of what most of these topics are taught. It is a reverse of what most of these topics are taught. Yep. So, I want you to understand why promises are so important. Mm-hmm. Yeah, it is the reverse of what most of these topics are taught, right? So, but I want to understand why promises are so important, exactly, and understand why promises are so important. Yep, yep. The TLDR is like this. The TLDR
because they're not perfect. And when there's some frustration with a promise or something that's weird or there's some gotcha, there are gotchas there. And when there's
Mm-hmm. So they are not perfect, and they got gotchas. Jesus, oh my God.
some gotcha down the road and you're frustrated and you find yourself, here's a clue, there is such a thing as promises hell. If there's a callback cell, there's a promises hell. When you find yourself stuck in promises hell and you're cursing at them, I don't want you to turn around and say, well, I can just get rid of promises. You need to understand why they're more important than just the usage of their API. If I could change it, there are some things I would change about the API. But I wouldn't change the fact that they're there. They are one of the most important advances that we've made in codifying reasonable asynchronous coding patterns.
Mm-hmm. They're not perfect and they got gotchas, but they are a good. Mm-hmm.
So, but I wouldn't change the fact that they're there. They are one of the most important advances that we've made in codifying reasonable.
Mm-hmm. But they are a good.
Could change it. There are some things I would change about the API. But I wouldn't change the fact that they're there. They are one of the most important advances that we've made.
Mm-hmm. But they are, exactly. But they are one of the most important advance that the GS community has made
Codifying.
in codifying concurrency, or in codifying reasonable asynchronous coding pattern. In codify reasonable asynchronous coding patterns. Mm-hmm. They are not perfect, and they got gotchas, and they. But they are one of the most important advances in the JavaScript community. That's one of the most important advances the JavaScript community has made in codifying reasonable asynchronous coding pattern. In codifying reasonable asynchronous coding pattern. Codifying reasonable asynchronous coding patterns. So by the time we need to deal with this concurrency, this asynchronicity, this task that overlaps at the time, promise has been one of the most important advances in the JavaScript community. And understand what is a promise by using some of these 2 or 3 explanations by way of metaphor and illustrations, so we can understand why they are so important, and also explain that using one of these metaphors.
Reasonable asynchronous coding patterns. So, first, let me give you a scenario around promises. It's silly. It's early here together, and I want us to make sure that we're all kind of awake.
Okay. So first, a silly scenario possible.
I see people sipping on coffee, so have more coffee.
Sipping on coffee.
You're gonna have to fire on silly It's early here together, and I want us to make sure that.
So it is early here together. By the time that was recorded. Okay. So I want to make sure that we are all kind of awake. So I want to make sure we are all kind of awake.
That we're all kind of awake. I see people sipping on coffee. So.
I see people sipping on coffee. Sipping. Interesting. That's one of the reasons why I'm transcribing this. Sipping, but this is sorbiendo. Sipping coffee. Bebiendo, pero a sorbos. Sorbiendo. Sipping, pero es bebiendo. Por degustar. Sipping, no es tanto. Significa sorber. Sipping, exacto. Sorbiendo. Beber aspirando. Sorber. Atraer hacia dentro de la mucosidad nasal. De sorbitos. Libar, chupar, succionar, mamar, absorber. Exacto, pero es sorber. De a poquito. That's interesting. Okay.
So have more coffee.
Sipping coffee. Because your brains are going to have to fire on all cylinders to get stuff today.
It's early here together, and I want us to make sure that we're all kind of awake.
Modern components on page. Mm-hmm. Anyway, move on with promise, man. We move with promise.
See people sipping on coffee.
It's like sipping on coffee, bro. Sipping on coffee, bro.
So have more coffee because your brains are going to have to fire on all cylinders to get.
And all cylinders. Okay. So, yep, you better get ready. Sip coffee. Sip coffee because your brain are gonna have to fire.
Here together, and I want us to make sure that we're all kind of awake. I see people sipping on coffee, so have more coffee because your brains are going to.
I see people sipping on coffee, so have more coffee because your brain is going your brain is gonna fire. So because your brains is going because your brain is gonna have because your brain is gonna have to fire in all cylinders. That's one of the reasons I love this sensation of the motorcycle. It's like that was powerful. The sensation of getting in. Oh my God. The sensation of getting on top of a motorcycle or something that actually makes some noise And if you're using, I don't know, some machines are using V8 engines or 2 cylinders, it's like, that sensation. Oh my God. Yes. So you better get ready because here we're gonna. Well, actually, I'm not sipping coffee, and actually is drinking. Sipping. Sipping is ginger water. Yep, sipping ginger water because my brain is my brain will have to fire all cylinders to get stuff today. Oh yeah, it is.
I have to fire on all cylinders to get stuff today. But here's a silly metaphor to explain to you. I walk up to the counter at my favorite.
Exactly. But here is the silly metaphor, right? Metaphor.
Favorite fast food restaurant. They're going to have to fire on all cylinders to get stuff today. But here's a silly metaphor to explain to you. I walk up to the counter at my favorite fast food restaurant.
Okay. I walk up to the counter. Interesting. I walk up to the counter. Yo voy a la caja registradora, ¿ok? No, yo voy hasta el que está en la caja registradora. I walk up, yeah. I walk up to the counter. I walk up to the counter of my favorite pizza restaurant. Yep, of my favorite pizza restaurants. And I order, and I order. And I order chili pizza, right? And I order chili pizza, hot chili pizza. Exactly. Yeah. And I order chili pizza. Yeah, I love that. Yeah. And I order chili pizza. Okay.
So I asked the lady, I'd like a cheeseburger.
Very good. So I asked the lady, I like, interesting, I like. Okay, that's a subtle difference here. I want and I like as a way to make an order. I like to have, right! Okay, things started to make sense here. I like to, I want to, I like to, okay. So I asked the lady, and I like a chili pizza. I like a chili pizza, right? She says,
that'll be $1.39.
And she say, that'll be dollar 3.49. 3.49.
And so I hand her the money.
It's a very cheap pizza, right? That's gonna be 10. No? That'll be 10.49. So I hand over the money. All right, and so I hand her the money.
Give her the $1.39. So I've begun a transaction by.
So I hand over the money. $10.49. So I began exactly. So I began a transaction. So I began a transaction by ordering.
Giving some money for something.
Exactly. So I began a transaction by ordering.
He says that'll be $1.39.
Yeah, but I began a
And
transaction here.
Give her the $1.39. So I have begun a transaction by ordering.
Exactly. So I began a transaction by ordering and giving it. Exactly. By ordering and giving it $10.49.
Giving some money for something. What am I expecting in return of this transaction? I'm expecting a cheeseburger.
Exactly. So what am I expecting out of this what am I expecting out of this? My chili pizza.
But oftentimes I'm not handed a cheeseburger immediately.
But oftentimes you are not get your pizza immediately.
Giving some money for something. What am I expecting in return of this transaction? I'm expecting a cheeseburger. But oftentimes I'm not handed a cheeseburger immediately.
But oftentimes I'm not handed. But oftentimes I am not handled. Exactly. I am not handed. But oftentimes I am not handed a. But oftentimes I'm not handed a. Yeah, but oftentimes I'm not handed a pizza, a chili pizza. Instead, what am I getting? Instead, I receiving a receipt. Okay, I'm receiving a receipt.
What instead am I given? A receipt.
Exactly. So what instead I am given? Or what instead am
in return?
What instead I'm given?
I'm expecting a cheeseburger. But oftentimes I'm not handed a cheeseburger immediately. What instead am I given?
Exactly. What instead am I exactly? What instead am I given? Am I given a receipt? A receipt. But oftentimes I am not handed a chili pizza. But oftentimes I'm not handed a chili pizza. En la mayoría de las veces no me dan una pizza que estoy obteniendo a su vez. What am I getting? What am instead I'm given? What instead I'm given? A receipt. What instead I'm given? A receipt. Y yo que estoy obteniendo a cambio. What instead I'm given?
A receipt. And importantly, on that receipt, it has an order number on it.
A receipt. And exactly, a receipt. And importantly, on that receipt, it has a number on it. A receipt. And importantly, on that, I got a number on that.
Right? My order says order number 317.
My order says order 3017.
So I take that receipt, a receipt, and importantly on that receipt it has an order number on it, right? My order says order number 317.
Order 3017.
immediately. What instead am I given? A receipt. And importantly, on that receipt, it has an order number on it, right? My order says order number 317.
317.
So I take that receipt and I look at my order number, and that order number.
Okay. So I take that receipt. So I take that receipt, and my order numbers becomes the chili pizza, but my order number has become a placeholder. Exactly. So I take the receipt and my order numbers, and the order number has become a placeholder. And when you say a placeholder, placeholder is some sort of placeholder is some sort of muesca, some sort of placeholder. Referente, a placeholder, okay, as a reference. Placeholder, como un referente. What? La partícula. Yeah, what is a placeholder? And es pues acertado. Es acertado decir un espacio temporal o provisional. It's a placeholder. Un guardador de lugar. Okay. So a placeholder is guardar espacio. Placeholder. Donde guardas espacio, alocador de espacio. Relleno. Placeholder. Es como un lugar de relleno. It becomes a placeholder. It becomes a hole. It becomes, se convirtió en un lugar. It becomes a placeholder. Se convirtió en un lugar. Se convirtió en un lugar provisional. Se convirtió en un lugar provisional. Exacto. Exacto, un lugar provisional. Captura la idea de espacio y que es temporal. Placeholder. Ok, so placeholder es un lugar temporal, ok, en el que se convirtió mi pizza y este recibo. El recibo se convirtió entonces en un lugar temporal, un espacio temporal de mi pizza.
Has become a placeholder for my future cheeseburger.
So I take that receipt and my order number has become a placeholder for the chili pizza.
Order number 317. So I take that receipt and I look at my order number, and that order number has become a placeholder for my future cheeseburger.
And that has become a placeholder for my future chili pizza. That's exactly. So that receipt has become a placeholder for my future pizza in this case, right? Ese récipe, ese aval, o ese lugar ese recibo se ha convertido en mi lugar de depósito temporal de mi futura pizza.
It is an IOU, it is a promise for a future cheeseburger.
It is an IOU. It is a promise for my future. It is a promise for my future cheeseburger, or in this case, for my future chili pizza.
They owe me a cheeseburger because I have given them money. I've started a transaction.
So they own me a chili pizza because because I hand over the money. I started a transaction.
Now, I don't have the cheeseburger yet.
Yeah, I've started a transaction. I handed it over the money, so I started transaction here.
I can't bite into it, but that doesn't mean I can't begin to think about and reason about and dream about my future cheeseburger. I can begin to think about it, and my but that doesn't mean I can't begin to think about and reason about and dream about my.
Yeah, but that doesn't that doesn't mean that I'm starting to think about or dream to start to think or dream about my future chili pizza.
Future cheeseburger. I can begin to think about it, and my mouth can begin to salivate, and I can begin.
I can begin to think about it in my mind. I can begin to think about it, and my mind start to salivate. Pavlov ducks. Pavlov dove. Salivando como el perro de Pavlov, mano. Salivando como el perro de Pavlov, amigo.
And to have cheeseburgers dancing in my head about how amazing this cheeseburger is going to be. I'm famished. I can't wait to eat it.
Salivate and thinking about my mind start to salivate, thinking pizzas, dancing around, dancing around. Oh, or I can think of that woman dancing around, man. Lingerie woman with pigs is, oh my god, it's I get, it's the idea, man. It's this, man. Is this what it is, man? Is this what it is? This is what drives males here. This is what drives males here. And I can start to think. If you use that pigs example for a woman example, it's kind of the same thing. We're starting a transaction here. And this is something interesting because you can apply that to real life. And famish. I can wait to eat. Famish. Famish. Meaning, oh my god. Very hungry. Famish. Oh my god. Famish. Famish. I'm famished. I can wait to eat it. I can wait to eat it. I'm famished, man. I'm famished. You say I'm hungry? I'm famished. I'm famished. Okay? I'm famished and I can wait to eat. I can wait to eat. I can wait to eat it. I'm famished. I can wait to eat it, man. Oh my god. Yeah, it is.
I have something in my hand that allows me to begin to reason about this cheeseburger even though I don't yet have it.
I have something in my hand that allow me to reason about it that I'm not having it.
And then those magical words, order 317.
And then those magical order 317 printed on me.
And I walk back up to the counter, receipt it.
Then I walk back. Exactly. So then I walk back. In this case is this. Then I walk back to the counter. Then I walk back to the counter, receiving the hand. and then I walk back to the counter, receive it, receive in hand, order 316 printed on it. Okay, receive in hand. Okay, so I walk back to the counter, receive in hands, order 317 printed on it.
In hand, order 317
Order
printed on it. And I hand her my receipt, and what do I now get in return? I now am exchanging that promise to the counter. Receipt in hand, order 317 printed on it. And I hand her my receipt, and what do I now get?
And I handed out my receipt, and what I receive in return. Yeah, and what I receive in return. And what I receive in return.
I now am exchanging that promise for the value.
So, and now I am exchanging that promise. Now I am exchanging that promise for the value. For the value itself. For the value itself.
Value for the value itself. This is a silly metaphor, but a metaphor nonetheless for what is happening with promises. Promises are a codification of the idea that we need a placeholder.
So promise is a it's an idea.
Nonetheless, for what is happening with promises. Promises are a codification of the idea that
promise is the codification. Promise is the codification. Promises are the codifications of an idea. Codification is a codification of an idea that we need a placeholder, the secret place, right? This temporal secret place. Okay. Promise are a codification of an idea that we need a placeholder.
We need a placeholder to eliminate time.
To eliminate time from consideration. Wrapping around a value. To eliminate time.
Time is the concern wrapped around a value.
Okay. So promise are the codification of an idea that we need a placeholder to eliminate time.
Promises are a codification of the idea that we need a placeholder to eliminate time as the concern wrapped.
To eliminate time as the concern. As the concern around a value. The concern wrap around a value.
Wrapped around a value. We need a container around it. In programming speak, we call that a future value.
We need a container about it. In programming, this is called a future value.
It's a value that will eventually, at some unspecified point, become fulfilled, but in the meantime, we still need to be able to reason about it exactly the same way. Because we don't want that will eventually, at some unspecified point, become fulfilled, but in the meantime, we still need to be able to reason about it exactly the same way. Because we don't want to sit around waiting and wondering and having all these quirks of different logic. That's the complexity that makes our code hard to understand, hard to maintain, because we don't want to sit around wait. Actually, at some unspecified point, become fulfilled, but in the meantime, we still need to be able to reason about it exactly the same way. It's a value that will eventually, at some unspecified point,
So it is a value that at some point in the future, okay, it is a value that at some point in the future will get that, but in the meantime we want to reason about them like a like an order, like a pizza order in a restaurant. Okay.
Become fulfilled, but in the meantime, we still need to be able to reason about it exactly the same way, because we don't want to sit around waiting and wondering and having all these forks of different logic.
So because we don't want to sit around and wondering with all of this logic, having all these forks and different logic, wondering and having all of this fork of
That's
different logic,
complexity that makes our code hard to understand, hard to maintain,
different
hard to debug. So the promise
of different logic, which makes our code hard to understand, to read, and to debug. So promise becomes a container that wraps around a value.
Container that wraps around a value. In fact, promises come.
So promise becomes a container wrapper around a value.
Come to us primarily by way, they're not original to JavaScript, but they come to us primarily by way of a language called E.
Interesting. So promise comes to us primarily not in JavaScript, but by a language called GE.
One of the members of the TC39 committee, Mark Miller.
So one of the members of the TC group committed.
They're not original to JavaScript, but they come to us primarily by way of a language called E. One of the members of the TC39 committee.
One of the members of the TC39 committee. One of the members of the TC39 committed, Mark Miller, the creator of the E language.
Mark Miller is the creator of the E programming language. And in E, they have these things called futures. And in E, a future is literally replaced by its value.
And they have these things called futures. What is literally exchanging it is by its value, but you can perform the operation
by its value, but you can perform the operations that you would normally do against that value directly, transparently. Even though the value isn't physically there yet, you can begin to compose it, you can begin to perform operations.
So you in E, you can work with that future value like if that is there. and perform some operations, but when perform some operations and perform some operations. Mm-hmm.
We didn't get quite the same thing, but he said, you know what, this is really powerful in E.
We didn't get quite the same thing in JavaScript, but it is very powerful in E.
We should bring something to JavaScript that allows people to reason about values. Ignorance of the timing. Values are the important thing, and composing values is the important thing. If it sounds like it's kind of related to functional programming, it's because it is. Not the
it is quite so it is quite so it quite sounds to programming languages, to functional programming, since we want to reason about future values. We want to
in E, we should bring something to JavaScript that allows people to reason about values. Ignorance of the timing. Values are the important thing, and composing.
Exactly. So we want to reason about getting values and composing function and composing values independent or ignorant of time.
Values is the important thing. If it sounds like it's kind of related to functional programming, it's because it is. Not to throw back in those terms, but promises, not their API, but their mechanism, they're basically a monad.
Mm-hmm. So, okay, so promises are basically a monad. So we don't know what a monad means here.
They're a functional programming concept.
They are a functional programming concept. That's pretty fucked up, bro. That's pretty fucked up. So promises are basically a monad. And what is a monad here? Explain a monad like M5. Imagine you have a magical lunchbox. Here we go with the lunchbox and the kind of thing. It is special because it does three things. It can hold your sandwich, like in this wrapping your data. It has rules about how you put things, like wash your hands first. Magical lunchbox. It has rules about how to put things in, like wash your hands first, or it has some sort of restriction. It can hold your sandwich. It has rules about how you put things, and it has rules about how to take things out and change what's inside. So this is interesting because there's this magic box that has a set of constraints, okay, that it does three things. It allows you to hold things, hold a sandwich in this magic lunch box, hold a sandwich. It has rules of how to put things, okay, and it has rules of how to get things out, or how to take things out or change what's inside. Here's how it works. You can put a sandwich in the box. This is called return in monad term. You can swap your sandwich for a cookie, but only following the lunch box rules. This is called bind in monad terms. Okay, the launch box makes sure everything stays clean and safe. In programming, a monad is like this magical lunchbox. It wraps up data like a sandwich. It has rules of how to put data, and it has rules about how to transform what's inside. The most common example is probably the maybe monad. It is like a lunchbox that might be empty. Before you try to eat what's inside, it tells you if there is actually anything there, and this stops you from trying to eat from an empty lunchbox. Would you like to give me some simple programming example of how these things work? Please do. This is like our lunch. And it has some rules on that. So this is a magical place where you can store things. You can hold yours and you can hold values. Okay? Maybe. It can hold values. Alright, they're all private. But it can hold values. Okay? And it has some rules of how you do this. And it has some rules of how you put data in it. Okay? So call this function get pets here, and you're going to return is maybe pet.get name. All right, getting a pet toy, get pets, get toys. All right, return pet.get. You got the pets, okay, pets database. And let's try to get fluffy toys safely. So you say, hey, I'm going to now call this class with this and bind them to get toys. And this is now the way how you change this. Fluffy toy is maybe ball. Let's try with a pet that doesn't exist. Maybe ball. And bind that get toy. Pet.get, the favorite toy. That's a way to access data here. And it has a particular way to access this data. And let's try with a pet that doesn't exist. Sparklers. Maybe none. All right. Again, I don't want to dive deep too much into this, but yeah. So a monad is like a wrapper. The maybe monad help us handle errors gracefully, no crash when things are missing, change operations safely, like going from user profile and email, make our code clean and easy to understand. Think of like a protective bubble around a data. We can always safely look inside of it and transform what's there, but we never have to worry about the bubble breaking if it is empty.
API is not quite as clean as a functional programmer would like, and there have been experiments to create other versions that are more functionally sound, but the principle is still the same. So if it sounds functional, it's because it is. So that's one way of thinking about a promise, is that it's a future value. Another way of thinking about a promise is that it uninverts the paradigm that we're traditionally used to interacting with some other mechanism that's going to be asynchronous in nature. When I call some utility, and I know that utility is not going to finish now, it's going to finish at some later point. When I call that utility, how do I wait around to hear that? I have to give it a callback. I have to pass the callback in. And you remember I said that's the inversion of control. When I wrap up the second half of my program in a callback and pass it to someone else, I give them the continuation control, and now I've inverted the control that I have. But what if we could uninvert that paradigm? If we could uninvert, or rather not invert it in the first place, rather than passing a callback to a utility, what if we could say something like, I'm going to call some function, and I know it might take a while for it to finish. I want you to return to me, when I call you utility, I want you to give me back something. I want you to give me an event listener. An event listener that I can subscribe to a completion event.
and I want to subscribe this. So give me now, exactly, so give me now as a subscriber here. This is interesting. It's like, give me now a subscriber here, that by the time you get that, I'm just going to now, when I call this.
I want you to give me back something. I want you to give me an event listener.
Exactly, give me now an event listener here.
That I can subscribe to a completion event.
That I can subscribe to a completion event.
So I'll listen for the completion event, and you just fire that event whenever you're good and ready, and I'll be notified through this event listener that you've finished your work, and I'll know it's time to move on. In fact, in addition to being a completion event, I could also listen to an error event. If you had some error to notify me or other things that you wanted to notify me about, I could simply receive an event listener back from you, and I know that's a tried and true pattern to receive something and listen to it. Listen, subscribe to event sign. So back to our track checkout, if you recall from before, that silly scenario about the e-commerce. And rather than passing my call back in, what if we were to modify that API such that it returned back an event listener to us? As you see on line 11, I receive a
Okay, so that'll be all for this video. Take care. Bye-bye.